In this video, I'm going to show you how to run a binary logistics regression in SPSS. Here I have two independent variables, temperature and flyers, and a single dependent variable which is dichotomous in nature, sales being grouped as below average and above average, and I want to see how I can be able to predict sales in a particular day to be either below average or above average based on two independent variables. To do this, I go to analyze, and then in analyze I click on regression and then binary logistics. For the binary logistics, I want to move the dependent variable, in this case which is sales being, to the dependent variable field, and I'm also going to move temperature and flyers into the covariates field. And then again I'll click on options to choose some statistics. So I'll click on the classification plots, I'll click on the goodness of fit, the case wide listing of residuals, and I'm also going to click on iteration. And then just in case I want to change the 95% level of significance, I'm going to also check this. Okay, I'm going to also leave outliers outside checked the way it is, and then I'm going to change from at each step to at last step. And once this is done, you can click on continue and then you click on OK. SPSS is going to run the analysis and give you the results in the output view. Now SPSS is going to give you lots and lots of table, but I'm just going to show you the few ones that are important, that you need for your analysis. So to do this, I'm going to show you. Firstly, the table I would want to concern myself with is the model summary. Now, the model summary here, I want to look at the Cox and Snell R squared, which is also called the pseudo R squared. It tells you what percentage of the variation in the independent variable can be accounted. The dependent variable can be accounted for by the independent variable. Here we see that this is 0.686, which is same as 68.6%. What this implies is this, that between 68.6% and 91.5% of the observed variation in the dependent variable can be accounted for by the independent variable. And then again, another table that I want to show you is the classification table. Remember, we are trying to predict an event that sales in a particular day is going to be below average or above average. Now, SPSS classifies a particular event as occurring if it is more than 0.5, that is more than 50%. If it is below 50%, it classifies it as not occurring. Here we see what this implies is this. Now we see that 94.7% were correctly classified as below average, and 93.8% of the observations were correctly predicted as above average. Then again, I'll also want to show you one other table that we need for interpretation, and that is the variables in the equation table. This is the one that shows us whether our prediction for the prediction of each of the independent variable in predicting the dependent variable is significant. Here we see that temperature is a significant predictor of sales at a very high significance level, way less than 0.5% level of significance, and that of flyers also is significant. We see here that the p-value is 0.032, which is less than 5% level of significance. And then again, if we want to build a binomial regression model for this, we can be able to use the coefficients here to build a model. In case you want to learn more about binary logistics regression, you can register for the Kennex Edu Research and Data Analysis Masterclass. So this is how to run a binomial regression analysis in SPSS.